All right, section 1.6 again. Continued for the what, third time now? Yeah, this is 1.6c as far as the worksheet is concerned. Let me find a good problem here from the example. All right, what we're going to do is we're going to do some of the same stuff we've done in basic Algebra 1, but we're going to do it with exponents, and we're going to do it with fractional exponents. So we've done distributive property, right? You know regular distributive property. That's basically what we're going to do, except we're going to do it with crazy fraction exponents. So here's the first example. So it's m to the 2/3, and in parentheses m to the 7/3 plus 2 m to the 1/3. And all this is basically, it's nothing new. It's just a matter of remembering what the rules are when you multiply with exponents. Okay? So what is the rule when I multiply by exponents? I keep the base the same and I do what? I add the exponents, right? Okay, so let's add the exponents. So 2/3 plus 7/3, what's that? It's 9/3. What's 9/3? It's just 3, isn't it? You can do that in your head, can't you? Sure. Okay, no calculators. Don't pull your calculator out and put those in as fractions. All right, you got a common denominator. They rigged this to make it real easy for you. You got a common denominator. All you got to do is add the top. 9/3 comes out even to 3, so we write it as 3. See that? So I'm distributing is all I'm doing here. Plus. Now you got a whole number out in front of coefficient. So, and you actually have a coefficient here too, don't you? You don't see it though, but it's a 1. So 2 times 1 is just 2. Now let's multiply the m's together. So they've got the same base, so we keep the base the same and we add the exponents. 2/3 plus 1/3 is 3/3, and 3/3 is 1. So it's just 2m to the first. And then I'm finished. That's all there is to that. You could put a 1 here if you wanted to, but do you need it? No, you don't need it, so I'm not going to put it there. That's it. That's all there is to that. Wow, that just seems too easy, doesn't it? I ran out of examples on my little, on my personal notes. Let me find one in the book, and then because there's another one. Well, I'll tell you what. Let's just make one up. All right. So let's go. I don't know. X to the 5/7. We'll use 7 as our denominator. Let me find one. Let's say minus x to the 2/7. Yep. And let's do this. Let's square. All right, again, this is nothing new. We've talked about this before. When you have a parentheses and it's being squared, do you just square the stuff inside of there? You take this and square it minus this square it and you're done? No, what did we say? I've harped and harped and harped on this. What do we do? Times it by itself. Exactly right. You got to multiply it by itself. So you're going to do the FOIL method here, aren't you? So it's x to the 2/7, and then we do the same exact thing. All right, that's very important. When you see something's being squared like this, you've got to write it like we have here. And now it's just basically doing the FOIL method. So let's do that. Let's do the first. If I multiply those together, again, remember the rule. Say that rule to yourself sometimes. You keep the base the same, and what do you do with the exponents? You add the exponents. That's right. You add the exponents together. So 5/7 plus 5/7 is what? Denominator stays the same, so you just add the top. It's 10/7. Everybody with me on that? All right, that's the first. What about the outside? Well, positive times negative, that's a negative. And let's do those. The base is x. So it's x to the 5/7, x to the 2/7, which is x to the 7/7, which is just an x. Very good. All right, makes sense? All right, so that was the outside. What about the inside? It's the same thing, isn't it? Yep. So that's just a minus x, right? 2/7, 5/7 is 7/7. You got it. Then last, negative times negative, which is positive. And then let's do that. That's going to be x to the what? 4/7. Good. We just leave it like that? No. We would write x to the 10/7 minus 2x plus x to the 4/7. Now what do I do? Do I add 10/7 to 4/7 right here? It's a common denominator, right? So what do you think? Do I? When do I add exponents? when you multiply. Are these being multiplied together? No, they're not. Okay, you can only add what? What's the phrase? Like terms, right? You can only add like terms. Is 10/7 and 4/7 like terms? Watch. If I have x squared, can I add that to x to the 5th? No, they're different terms, aren't they? X squared, x to the 5th are completely different terms. Same thing here. X to the 10/7 and x to the 4/7 are not the same term. All right, they're not the same. They have to be exactly the same, and they're not. That's 10/7, that's 4/7. It's not even close to the same. So you can't do anything else with that. The only thing you can do, circle it, and that's your answer. You got it? Make sure. Now, I asked you that. I mean, that was a trick question. All right, I asked you that to get you thinking about it, because a lot of people do it. In my experience of teaching this stuff for many years now, is that people look at this and say, oh, 10/7, 4/7. Oh, that's 14/7. 14/7 is squared. Oh, yeah, it must work out real nice. No, it doesn't. All right, you can't add those together. They're not like terms. Make sense? All right. So that's about almost half. That's 4 of your 10 problems that you're going to have on this worksheet is this stuff like this, okay? The next part is a little bit tricky, so we got about 10 minutes left. So let's pause this, and I'll start on the next part. All right, let's go back in time a little bit. If I asked you to factor this thing right here, okay, first thing you would do is look for a greatest common factor, would you? Yeah, it's not one of our special factoring. It's not a difference of 2 squares. It's not a perfect square. It's none of those other kind of things. It's not a difference of 2 cubes. It's none of that kind of stuff. All you do is look to see if you have a greatest common factor. So let's go through this. Now, I'm doing this on purpose, all right, because we're going to do one a little bit that it's not quite as easy as this. So what about the coefficients? I got an 8 and a 2. So what's greatest common factor with 8 and 2? 2. All right. What about the x to the 5th and the x squared? What's in common with both of those? What is it? The x squared. That's right. Now look, x to the 5th is bigger, isn't it? X to the 2nd is smaller. So which one did we pull out of there? We pulled out the smallest one, didn't we? That's the greatest common factor because the smallest one is in both of them. Got it? So that's an x squared. Does that make sense? Now think about what I just said, because we're going to use that reasoning a little bit. So if I pull this out of here, how do we figure out what's inside the parentheses? Well, we take this, and what are we doing? We're dividing it by this thing right here, aren't we? So 8 divided by 2 is 4. X to the 5th divided by x squared is x to the 3rd. Now, how did I do that? What math did I do when I divided? Subtracted, right? I went 5 minus 2. Again, keep that in your mind because we're going to get back to that, okay? I'm doing this for a reason. Minus, what about this? 2x squared divided by 2x squared. Well, guess what that is? It's a 1. Don't forget that 1. You can't just say 4x cubed, can you? You need the 1 because if I went ahead and distributed, I'd have to end up with what I started with right here. So I have to have the 1. Are we okay with that? All right. That's pretty important. That's just real basic, straightforward, greatest common factoring. Now we're going to do one, but our exponents aren't going to be as nice and pretty as this. They're going to be fractions, right? That's what we've been working with, hasn't it, lately? So they're going to be fractional exponents. So let's write it like this. Let's write 12x to the negative 2nd minus 8x to the negative 3rd. And we're going to factor, okay? This word factor just continues with all these. This is what we're going to do is we're going to factor. First thing we do is we look to find our common factor with our coefficients. I got a 12 and an 8. What's the biggest number that divides evenly into 12 and 8? 4 does, right. 4 goes into both of those, so we factor out of 4. Now we look at the x's. Now, I said fractional exponents earlier, didn't I? This one's not a fractional exponent. We'll do those in a second. But this one is a negative exponent, though, so it's a little bit different. Now, remember what I did. How do I know which one is in common with both of them? I took which one? I took the smallest of the two. Now, this is a little different, okay? I got an x to the negative 2nd and an x to the negative 3rd. What's the greatest common factor with both of those? Well, what do? We take the which one? The smallest one. Which is the smallest one? Negative 3 is smaller, right? Negative 3 is smaller than negative 2. Would you agree? All right, and a lot of people will take an x to the negative 2 out. But that's not the smallest. Okay, you take the smaller one. You get it? So that's a little bit tricky. So you take x to the negative 3. That's your greatest common factor. Let's figure out what's left over. Well, we take this and divide it by this. So 12 divided by 4 is 3. Now, this is a little bit tricky as well. It's x to the negative second divided by x to the negative third. So what's the rule? The rule is you do what to the exponents? Come on, what's the rule? You subtract, right? Right here, isn't it? We factored this out. We went x to the fifth over x squared. We subtracted the exponents. So let's look at it. What are we subtracting? I'm subtracting negative 2, right? I'm taking this and dividing it by this. So it's x to the negative second. Watch. It's x to the negative second over x to the negative third. That's what you're doing, isn't it? All right. So what happens when you subtract? It's negative 2 minus. Is it minus 3? No, it's minus negative 3. What's minus a negative? Right? So it's negative 2 minus negative 3. What's minus a negative? It's plus. So what is this going to be? It's just going to be x to the first. Do you see it? Okay. Minus. Now let's take this. Let's take this and divide it by this thing right here. Well, 8 divided by 4 is 2. X to the negative third divided by x to the negative third, that's just a 1, isn't it? You see that? And then that's our answer right there. Now remember over here I said you have to multiply it out to get this. Let's see if it actually works. All right, that's to the first. Watch, 4 times 3 is 12. That works, doesn't it? X to the negative third times x to the first. What's that? Negative 3 plus 1 is negative 2. So that's x to the negative 2. That works, doesn't it? All right, minus, let's do this. 4 times 2 is 8, and then what? X to the negative third. That works. So yep, we did it. We factored it. That's the greatest common factor, and that whole thing right there is now factored. You get it? It's the same kind of thing as we did here. A little bit trickier. You gotta know your rules. All right, when you factored it out, you took the smallest one, right? When you factored it out. That's in common with both of them. Same thing here. Negative 3 is smaller than negative 2. You could see where people would go wrong on that, couldn't you? Because people think, oh, 2 is smaller than 3, but these are negatives now. Negative 3 is smaller than negative 2. All right, let's do another one. All right, here's another one. Now we got a fraction. I said earlier we're going to have a fraction. Now this is one. So we're going to find a greatest common factor. Well, look at 4 and 3. Is there a greatest common factor? Is there anything that divides evenly into 4 and 3? No, except for 1. But so no, there's not a greatest common factor as far as 4 and 3. What about the variables though? This is m to the 1/2. This is m to the 3/2. Which one do we pull out? Smaller one, right? Which one's the smaller one? M to the 1/2. Everybody see that? And now we put our parentheses and we take this and we divide it by this thing right here. So 4, remember this is a 1. Technically the greatest common factor is a 1. So 4 divided by 1 is 4. And then what? M to the 1/2 divided by m to the 1/2 is just a 1. So that's just a 4. Plus. Take this and divide it by this. So 3 divided by 1 is 3. Look at this. It's m to the 3/2 over what? M to the 1/2. What's the rule? Subtract. So what's 3/2 minus 1/2? 2/2, which is just a 1. So what's that going to be? Just 3m to the first, right? You still have to have the m there, but the exponent is a 1, so it's 3m to the first. Just leave it like that, and you don't really need this 1 right there, do you? And that is your answer right there. All right. Now we have negative and we have fractions, so we find a greatest common factor. Now look, the coefficients are just 1s, so we don't have to worry about those. So which one do we factor out? Which one would be our greatest common factor? We factor out which one? The smallest one. So we factor out y minus 2 to the negative 1/3. Right. Let's figure out what's left. If I take this and divide it by this, I just have a 1, don't I? Everybody see that? Okay, plus, if I take this and divide it by this, what do I do? It's going to be y minus 2. And what do I do? Subtract the exponents. 2/3 minus negative. Minus negative is plus. What's 2/3 plus 1/3? It's just a 1, isn't it? All right. So you just write it like this. Now, we can simplify it a little bit. We can go 1 minus 2 to the negative 1/3. It's supposed to be negative 1/3. This is going to be what? Y minus 1. Everybody see that? Because 1 minus 2 is negative 1, and that's your answer right there. That's it.